Hello everyone, welcome to IIT-JEE NEET Foundation classes. In today's class, we are going to discuss atomic structure of the atom. In structure of the atom, we have so many subtopics. In today's session, we are going to start with atomic number, mass number and isotopes. Okay, let us start with what is atomic structure. Okay, in that atomic number and mass number. In atomic number, what is the definition for atomic number first? See here, it is the number of protons of an atom. In an atom, how many number of protons are present? That gives you the atomic number of that atom or element. Okay, see, it is represents with Z. All the atoms of the same element have the same number of protons in their nuclei and hence they have the same atomic number. See, we will go with example to explain this point. I will take calcium. Calcium is an element. In calcium, all calcium atoms will be present. In calcium atoms, if you take that calcium atomic number is 20, means the number of protons present in the calcium atom is 20 or 20. So, that 20 is called its atomic number. Wherever you observe, the calcium atomic number will be 20 only. There is no change in its atomic number. And atomic number 20 means always it's calcium only. It cannot be changed. So, it is the fixed unique number for every single atom or element. Okay. See, that is what here. No two elements can have the same atomic number. Out of 118 in the elements in the periodic table, each element will have its unique number. No two elements will have the same atomic number. Each and every element will have a different atomic number. Based on this atomic number only we can identify an element. What is the element like? Okay, let us see. Suppose carbon is there. The carbon's atomic number is 6. Means its Z value is 6. If you see, always that 6, atomic number 6 means it should be carbon only, because that 6 allotted to carbon. The number of protons present in the carbon will be 6. There is no change. No other element will have number of protons 6 in that nucleus. So, the number will be unique for each element or atom. No other element can have atomic number 6. See, in normal atom or neutral atom. See, what is this normal atom or neutral atom means? One atom is considered, as we know that it has some subatomic particles. Those are electrons, protons, neutrons, like, because we have studied this in the earlier theories, right? So, if one element has or one atom has same number of protons and same number of electrons. Protons means positive charge, electrons means negative charge. So, number of positive charges equal to number of negative charges, then it will be a neutral. Obviously, that's why we can say when an element or atom has same number of protons or same number of electrons, then that atom or element is said to be neutral. That is what here the neutral atom. In a normal atom or neutral atom, the number of protons is equal to the number of electrons in it. So, we can also say that the atomic number of an element is equal to number of electrons in a neutral atom also. So, we have two definitions for atomic number. The first one is number of protons present in an atom is called its atomic number, and the second one is number of electrons present in an atom gives its atomic number. So, number of protons represents with Z and number of electrons also represents with Z. But while talking about the number of electrons, we should consider the neutral atom only. Okay. Now, let us see the mass number. What is meant by mass number? Mass of an atom is practically due to protons and neutrons alone. The mass number means in an atom we have to consider the protons and neutrons only. We are not talking about any other subatomic particles, only protons and neutrons alone. So these are present, these protons and neutrons will be present in the nucleus of an atom. See, nucleus, suppose think it is the nucleus, like in the nucleus of an atom, they are presenting in the nucleus, so those are called nucleons. Protons and neutrons are presenting in the nucleus, so those are called nucleons. So see, here we have an example. Mass of carbon is 12 because it has 6 protons and 6 neutrons. 6U, U indicates its atomic mass units. So because it has 6 protons and 6 neutrons, that 6U plus 6U gives you 12U. So always the mass number of carbon will be 12 only. If you observe in this figure, the center is the nucleus and the blue one is the electrons revolving around the nucleus, and at the center of the nucleus there are red dots and black dots. The red dots represents the protons and the black one represents the neutrons. So how many are present? The total number of protons and neutrons present in the nucleus gives you the mass number, and those are called nucleons. And this is the figure for the carbon atom, right? Let us see another example. Aluminium. Its mass number is 27. The 27 means number of protons are 13 and number of neutrons are 14. See, this is the picture for aluminium. If you observe here, the yellow one are the electrons. The middle part is the nucleus and the electrons are revolving around the nucleus. If you observe in the nucleus, we have a two color. One is blue, one is red. That blue indicates the neutrons and the red one indicates the protons. Means the protons and neutrons alone combinedly present in the nucleus. Those are called nucleons. But electrons revolve around the nucleus in its free state. They are not combining with any other subatomic particles, right? So this is the structure, graphical representation for aluminium. And in this nucleus we have 13 protons. Why? Because aluminium's atomic number is 13. That's why out of 27, 13 are protons. Remaining 14 are representing the neutrons, right? So the 27 atomic AMU, nowadays we are representing with small u, that is called 13 protons and 14 neutrons. Totally it is 27U. For the aluminium, the mass number is 27 for aluminium. So next, what is the exact definition for the mass number? Let us see here. The mass number is defined as the sum of the total number of protons and neutrons present in the nucleus of an atom. Yes. Mass number means before carbon and aluminium, that is what number of neutrons and protons combinedly is called its mass number. That is what the definition here. See, the mass number of an element is denoted by A. Atomic number represents with Z. Here the mass number is denoted by A in the notation for an atom. So while writing an atom, how to represent an atom? The atom will represent like this. Here is the symbol of the atom. To that representation, lower side, left side, lower side will be the atomic number, left side, upper side will be the mass number. So the notation will be like this: X, Z, A. X represents the element, Z represents the atomic number, A represents the mass number. So for example, how to represent the nitrogen atom? Nitrogen symbol is capital N. So we will write first the capital N here, and to this number of protons present in nitrogen is 7. So its atomic number we are writing here, left side corner, lower corner, and the upper side we are writing the mass number 14. So the 14 is nothing but number of protons are 7, number of neutrons are 7 for the nitrogen, right? Next, what is the relationship between the mass number and atomic number? See here, mass number means number of protons plus number of neutrons. Number of protons plus number of neutrons. But already we know that number of protons means atomic number. So I want to replace in the place of number of protons atomic number. Then the formula will be mass number is equal to atomic number plus number of neutrons. Mass number equal to atomic number plus number of neutrons. Okay, that is about the mass number. Let us start with the isotopes. Let us see, start with one example. Here I am taking hydrogen. Hydrogen, it is the only one proton is present. So its atomic number is 1. Its mass number is also 1. So it is called protium because only one proton is present. So it is called protium. And the another one is the see here, deuterium. In deuterium, atomic number is 1 and mass number will be 2. In case of tritium is consider, atomic number will be 1 but mass number is 3. So what are isotopes? If you see here, this one we can represent as protium H. Atomic number is here, mass number is here, H11. Deuterium, hydrogen, its atomic number is 1 but its mass number is 2. Tritium, representation is H only element, atomic number is 1 but mass number is 3. So atomic number is 3. So these are, if you observe here clearly, 1, 1, 1. For protium, deuterium and tritium, its atomic number is same. But the mass number for protium is 1, deuterium is 2, tritium is 3. So mass number is differing but the atomic number is same. Those are called isotopes. See here, isotopes are the atoms of the same element having same atomic number but different atomic mass number. Those are called isotopes. So same atomic number, different mass number. Same atomic number means always it will be the same element, right? Same element with same atomic number but different mass number are said to be isotopes to each other. Let us discuss some examples. Here C612 means carbon isotope we are taking. C612. Here mass number is 12. Its atomic number is 6. Number of neutrons are 6. See here, already we discussed this formula. Mass number equal to number of protons plus number of neutrons. So we want number of neutrons only. So 12 minus 6. Mass number minus atomic number gives you the number of neutrons. So mass number is 12, atomic number is 6. So number of neutrons are 12 minus 6 equal to 6. Let us see next. C614. This is another isotope used in carbon dating like, right? So C614. Mass number is 14, atomic number 6. 14 minus 6 gives you 8. So the number of neutrons present in C14 isotope are 8. So next I am taking here chlorine. Chlorine example. Chlorine isotope, it is chlorine 17 and 35. Mass number is 35. Mass number means number of protons plus number of neutrons. Atomic number is 17. Mass number 35. Atomic number 17. So number of neutrons 35 minus 17 gives you number of neutrons means 18. See another isotope of chlorine. Chlorine 1737. This chlorine 1735, chlorine 1737. So same element chlorine, same atomic number 17 but differing in the mass number 35, 37. So these two are said to be isotopes to each other. Even in carbon also, C612, C614. Carbon is same, atomic number is same but differing in their mass number. Here it is 12, here it is 14. So those are said to be isotopes to each other. Okay, see here, its mass number is 37 and its atomic number is 17. 37 minus 17 gives you 20. Number of neutrons are 20. So same atomic number but differ in their mass number. These two are said to be isotopes to each other. So how to calculate the number of neutrons we learn from this table, and also we can say if number of neutrons are different, those are said to be isotopes to each other. Okay, or else isotopes will have different number of neutrons. Here carbon isotopes have 6, 8. Chlorine isotopes has 18 and 20. So number of neutrons in isotopes is different. Chemical properties of isotopes are the same. So number of neutrons will be different, but the chemical properties C6, C14 both will give the same product while reacting with any other molecule or compound. So chemical properties of isotopes are same, right? So this is the basic information about the isotopes. Let us see the diagrams of the two isotopes of chlorines are given below. Now C1735, C1737, two chlorine isotopes we have seen, right? So let us see that in the diagram, geometric graphical representation, like we can say this one. So let us see, it is the nucleus. In the nucleus 17 protons and 18 neutrons are present. Remaining electrons, it is a neutral atom, so 17 protons means electrons also will be 17. 17 new electrons are revolving in the different in the shells. So this is the graphical representation for the chlorine 1735 isotope. See here, nucleus contains 17 protons and 18 neutrons. Chlorine 35 isotope, mass number or atomic mass equal to 35. This is for another isotope. Chlorine 17, nucleus contains 17 protons and 20 neutrons. 17 protons and 20 neutrons means it is a chlorine 37 isotope. It has mass number or atomic number or is atomic mass is 37. So this is for chlorine 35 and it is for chlorine 37. These are the graphical representation of chlorine isotopes. Okay, see, mass number of an atom is equal to its atomic mass. Mass number only we are representing as the atomic mass. Okay, next, isotopes of hydrogen. Already we discussed this, the protium, deuterium and tritium are the isotopes of hydrogen like. Let us see, the hydrogen element has 3 isotopes having the same atomic number 1 but different mass numbers 1, 2 and 3. These are the isotopes H11, H12 and H13. Here name, isotope, protons, neutrons and electrons. See here, protium H11 isotope, it has 1 proton, 0 neutrons, because 1 minus 1, 0, mass number minus atomic number gives you number of neutrons, right? So 1 minus 1, 0, electrons are 1. Let us see for deuterium. It is for deuterium. Deuterium has H12, deuterium H12. It has 1 proton and it has 1 neutron, because 2 minus 1 gives you the number of neutrons. 2 minus 1, 1 and electrons are 1. Next, tritium H13. So it has 1 proton and 2 neutrons, because 3 minus 1, 2. So the number of neutrons are 2 in tritium and the electrons are 1. So same number of protons and electrons means atomic number is same. Number of neutrons are differing means mass number is different. So these H11, H12, H13 are said to be isotopes to each other. Okay. Next, it is clear from the above table that all the isotopes of hydrogen contain 1 proton and 1 electron each, but they contain 0, 1 and 2 neutrons respectively, means they are differing with their neutrons. So isotopes exist due to difference in the number of neutrons. Okay, is it clear? Now, the diagrammatic representation of isotopes of hydrogen are already given. This one we discussed. These are the diagrammatic representations. This is for H11, only one proton. Here one proton and one neutron. Here one proton and two neutrons. H11, H12, H13. These are the graphical representation for hydrogen isotopes. Okay, see. Isotopes of carbon and oxygen also we are discussing here. See, the carbon element has three isotopes. Those are same atomic number but different mass number of 12, 13 and 14. The three isotopes of carbon we can be written as like this. See here, these are carbon. In this nucleus, it has 6 protons and 6 neutrons. So, it is for C612. Here it is C612. Comes to here, it is C613, means it has 6 protons and 7 neutrons. 6 protons and 7 neutrons and its mass number is 13. The mass number is here 12, mass number is 13, mass number is 14. Means number of neutrons are 6, number of neutrons are 7, number of neutrons are 8. C612 isotope, C613 isotope, C614 isotope. These three are differing with the number of neutrons. So, these are said to be isotopes of carbon to each other, right? Now, see, next we are going to discuss about the oxygen's isotopes. In oxygen, these are the oxygen isotopes. O8, 8 protons, 8 protons, 8 protons. But these three are differing with the number of neutrons. See here, in the first one, 16, mass number is 17, mass number is 18. So, number of neutrons 16 minus 8. Here the number of neutrons are 8. So, here the number of neutrons are 8. Here 17 minus 8, number of neutrons are 9. And here 18 minus 8, number of neutrons are 10. So, 8, 9, 10. Number of neutrons are differing to each other. So, these are said to be isotopes to each other. Hydrogen isotopes are H11, H12, H13. Carbon isotopes are C612, C613, C614. Oxygen isotopes are O816, O817 and O818. Okay, this is about the isotopes of carbon, hydrogen and oxygen also we discussed and its definitions also discussed. Okay, thank you very much.